Hello guys, and welcome back again to another episode of the Babylonian Crypto channel. Today we're going to talk about this project called Arweave. This is one of the very high quality blue chip coins that I've been looking for, waiting, and finally it hit a very good price, which is around the support area of $30, and that's where I entered some positions, and I decided to do a deep dive research on what Arweave is all about. So the TLDR here is pay once, store forever. So you just pay one upfront cost and you can store your data on the blockchain for eternity. So the problem statement of Arweave is that blockchain is constantly producing more data at a faster rate at bigger sizes. And all this data actually needs to be stored by all these nodes and miners and validators. And the cost of running nodes actually starts increasing because all this storage takes up cost, and profitability margin starts declining, and it will eventually reach a point where it becomes too expensive and all these nodes start shutting down. Then it will eventually lead to centralization of nodes and GPU power, and then we go back again to Web 2.0. So it defeats the whole purpose of moving towards this decentralization Web 3.0 world, right? So the problem that we just described earlier can be seen on these two diagrams here. So here you can see that the more people who want to use and access the blockchain, the more costly it becomes to run the full node. So you can see that Ethereum for the past 3 years, the full node count has actually started declining as the usage and adoption of Ethereum goes up. So as the size of blockchain increase, the count of full nodes would decrease, and it will eventually lead to the centralization problem of Web 2.0. So for Arweave, there are a few things that make Arweave special. So one is this Blockweave data structure, and there are a few key concepts here: Blockshadows, SPoRA, which we will talk about later, and the storage endowment. So these two are the big ideas of Arweave data storage. So number one is that it uses proof of work plus this new concept called proof of access. So in a typical blockchain, the blocks are actually linked linearly, block by block. And then when you want to mine a new block, it actually takes in the previous block hash of the previous block. So the special thing about Arweave is that one of the requirements for miners to mine a new block is that it requires them to own a piece of the past data. So it will be a random block from the blockchain. It could be any block number, but you have to prove to the network that you own this historical data from block N in the network in the history. So the architecture of it looks something like this. So you can see here that a new block, if you want to mine, it actually takes the previous block hash and also the recall block, which is randomly generated through some algorithms, and the current transactions of the metadata. So you need all these components to form this BDS before you can do proof of work to find what is that nonce number. So the key idea here is that Arweave wants all these nodes to actually store a lot of all this data on the network. And additionally, it also encourages miners to store rare blocks, which is that means blocks that are not being stored by other miners. So if you store these rare blocks, then there's a higher chance of you winning because you have lesser competition now. So this in a way offset the rare blocks and the popular blocks, and so it encourages all the nodes to store as diverse and as many blocks as possible to have a more completeness of the data in the network. So instead of just spending computing power and spending large amount of electricities like proof of work to solve this nonce, now you also have another component, and that is the cost of storage, because now there is another equation, which is the probability of you storing a random data from a random block on the blockchain, and that is a cost also to the node, and this is the cost of storage. So now it is balanced between the cost of storage and the cost of electricity from a miner node perspective. But that's the old model, and actually there are a lot of problems with that way of doing things. So one is that this proof of access has no incentives for miners to retrieve data quickly, because it only requires you to have access to a random block, but it never says that you need to retrieve this data. It just needs to prove that you have this data. So a lot of all these miners actually start using all these remote storage pool data centers rather than storing it locally. So instead of you splitting the cost between cost of storage and cost of electricity, they choose to move more of their cost towards solving that nonce in a proof of work puzzle rather than using it to store data. So that defeats the purpose, because Arweave wants all the nodes to actually store data on the node itself rather than outsource it to a centralized server or something. So on February 2021, they actually upgraded to this Succinct proof of random access. And the difference here is that it adds the consideration for data access speed. So they favors miners who store data locally on their hardware. So now you have the cost of storage, the cost of electricity, how powerful your machines are, and the third component is how fast you're able to retrieve this data. And if you store this data on your nodes locally, then you eventually have a higher chance of winning the game. So the purpose is to promote data replication more aggressively, and the benefit is to improve speed of access to data retrieval, reduce CPU centralization, and then the secondary benefit is just reduce energy consumption. So another special thing about miners in Arweave is that they don't have to store all the entire blockchain, which is very costly and very time consuming, or at least you have to store the headers of all the blocks. But in Arweave, that's not the case. So you can read here, it does not require miners to store every previous block, and new users are able to join by downloading only the current block or verifying some backward portion of proof of work. So in that case, you can imagine that Arweave will not be a blockchain where you have blocks linked linearly, but rather it will be a Blockweave. Because if you think about it, the concept just now, each node actually needs the previous block, but also a random block from the network. So you can see that there will be like a spider web of different blocks that each node would hold. And the second part is that to actually optimize the speed and efficiency of all this propagation, they actually have these two concepts known as Blockshadows and Wildfire. So Blockshadows, it just means that the block construction happens locally. So what this means is that instead of propagating the full block to other nodes around you, to your peers, now you just need to send them the hash of the wallet list, the block hash list, and the list of transaction hashes. So you just send them the hash of all these things. But for the nodes to actually construct this block, it actually happens locally. So with this data, they are actually able to construct the block on their own node rather than from the transfer propagation period. And then the second part is Wildfire. So Wildfire is actually a ranking system where it will rank the nodes based on two things. So one is generosity. So this is when you have some data, how willing and how much are you sharing it out with others. And the second part is responsiveness. That means if people send you data, how fast are you receiving information. So these low ranking nodes will actually be blacklisted from the network. So probably the next question is, if each of these nodes actually don't store the entire blockchain, then what is the probability of a miner not owning a block whenever somebody wants to retrieve it, right? Because instead of the traditional blockchain, these miners don't store everything, don't store all the blockchains, so they only store a portion of the Blockweave. So Amber Group, they actually done a research to calculate the probability of a drop block, meaning that probability that there is a block that's not being stored by all these miners. So if the replication rate is 90% and the nodes is 350, is really almost zero. So replication rate is the ratio of the average number of blocks stored by miners. So for example, if the network has like 10,000 blocks and each of these miners store 6,000, then the replication rate is 60%. So the formula for calculating this probability is just 1 minus your replication rate to the power of the number of nodes times the total number of blocks. So for reference, now there are about 1,500 nodes and the replication rate is about 95-98%. So the probability of this drop block is actually very can be considered near zero already. So that's the whole idea of the mining incentive. So the next part here is this data storage cost. So just now we mentioned that in Arweave, users actually just need to pay once and they can store their data forever. But how do we calculate this data storage cost, right? So they use this assumption, which is how much does it cost to actually store for the next 200 years. And over the past 50 years, the data storage cost per GB actually has been dropping by 30% annually on average. And they use this assumption to calculate what is the current cost for storing over the next 200 years. But instead of using 30%, they are extremely conservative. They use only 0.5%. So this is really the worst case scenario. So this means that if the cost did not decline for 30%, decline by 0.5%, then you actually get at least 200 years of storage. But this is very, very unlikely because based on the technological advances in data storage and hardware, all this, it is likely going to accelerate. So if the annual cost reduction is actually higher, let's say it's 2% instead of 0.5%, then you get 300 years of storage. So for reference, this is how much it actually costs to store 1 GB of data on Arweave. It is about 8 USD, and in comparison to all these Web 2 solutions, this is how much it costs to store 1 GB of data per month on Amazon S3, Azure, and Google Cloud. So you can see is definitely much cheaper, but this is one is forever and one is just for 1 month. But if you just calculate like how much does it cost to store over the next 50 years for all these Web 2 solutions, then it is actually above $10 already. So in that sense, Arweave is actually cheaper compared to all these alternatives here. So storage endowment is another concept for Arweave. So the fees that you actually pay to Arweave to store your data forever, not all of them goes straight to the miners. Only 14% goes to the miner, and the rest actually goes to this endowment pool. And because the cost of storing data on the network is so cheap, the miners are actually profitable. So as long as the network fees plus the inflation rewards is greater than the cost to maintain this whole Blockweave data, then the miners are considered profitable, and this endowment pool won't be used. It is actually used for future conditions, scenarios where these nodes become unprofitable for whatever reasons. And in 2021, they also switched from SSD to HDD to further this lower operating cost for miners. So this storage endowment can be thought of as an endowment fund when you pay an upfront cost and you earn interest, but this time is in the form of higher storage purchasing power. Why is that so? Because as the cost of storage goes down, then your storage capacity increase, right? And people can store more things over a longer period of time. So this is a very strong buffer defensive mechanism for Arweave to react to any unexpected shocks of volatility. So you can find out how much they have in their storage endowment by taking a look at the latest block. So it's about 30,500 AR tokens that can be used for any purposes in the future. Okay, so this is an overview of Arweave over the past 1 year. And this is the number of transactions, and this is a total weave size chart. So total weave is just like how much data that is actually being stored right now. So it's close to 45 terabytes on Arweave, and transactions now they are close to 20 million, 25 million. And all this growth actually start skyrocketing only after July August period. And there are two components that actually drive this growth, and one is this bundles L2 scaling, and the other one is the NFT season on Solana in particular. So Metaplex protocol on Solana helps user to mint and deploy NFTs on Solana, and so far it has created over 5 million NFTs. And they actually recently just raised 46 million from Multicoin, Jump Crypto, Alameda, and all this. So Metaplex is a very important NFT player in the Solana and also in the Arweave ecosystem. And bundles is just a L2 scaling solution. It's just like your rollups. It bundles all your transactions and compress them into one single transaction. So this is the revenue comparison of Filecoin and Arweave. So they have been pretty quiet from Jan to August, and it's only until September that Arweave start making some noise and people start paying attention to it. So this is the revenue demand side protocol. This is based on a weekly revenue on Web3 index, and you can see again it's only Q3, Q4 that Arweave starts showing its true power. So Arweave adoption actually comes from these few things. So one is definitely NFTs, then second bundles, third is all these bridges, fourth is Permaweb, and fifth is this new profit sharing community concept. So Permaweb is just like your internet. It can store everything, files, videos, images, music, and applications, just anything, but except that this is permanent. So contrary to what many people think, Arweave is not just a database storage kind of protocol, but it also allows like applications to be built on top of Arweave. And bundles, as discussed previously, this is a very powerful scaling solution. It can store 2 to the power of 256 bytes, and that is a lot of data. And that's what makes Arweave so powerful, right? If you think about it from a scalability perspective. And then next is profit sharing community. So this is a new concept. So this actually allows all these developers to actually earn a share of the revenue through all these profit sharing tokens. So it incentivizes people to build dApps and deploy them on the network, because every fee transaction generated on the Permaweb that you have built, actually a portion of it goes to you. So you can earn recurring revenue from the network. So that's what PSC is about. So now we'll go into NFTs and bridges, which is the two main components for Arweave adoption. So in the past, NFT storage is very high. The content of NFT is actually not stored on-chain. In fact, what is stored on-chain is just the URL of the NFT and at most the ID of the NFT. The metadata of the NFT, including the image, the rarity, the attribute traits, the visual of how it looks and feel, everything is actually stored offline. And so what you are owning on-chain on the blockchain is actually just a URL link, and this metadata off-chain, wherever they are stored, can be changed in the next week, next month, or something happen here, then your NFT is gone. So if your NFT can become like this if the whole website goes down. So this guy actually do a review of the top 22 or 23 blue chip NFTs. I'll put his Twitter link down below. So he actually analyzed the metadata URLs of how all these NFTs are stored, and 50% of it comes centralized servers and 22% IFPS. So you can see that only a very small percentage, 4.5%, is actually stored on-chain. And the second part, and this is what I like best about Arweave, is that they are considered layer 0 chain agnostic. So you can see from this Twitter thread over here, as the broader crypto ecosystem grows, Arweave likely will too. It is L1 agnostic, so it does not care whether it is Ethereum, Solana, AVAX, Luna, Atom, or whatever. Everybody can use Arweave, and Arweave plan and ambition is to be the solution for all these chains, regardless of which camp you are from. So for Solana, they actually have this Solar Bridge. Then for Polygon, they are already natively integrated. This news actually came just Q4 of last year. And then for other L1 bridges like Near, AVAX, Polkadot, Cosmos, there's actually a middleware solution known as this Kive network, which is still under work. So this is the Solar Bridge for Arweave and Solana. This is the bridge that actually made Arweave so successful, because the Metaplex default storage is actually using Arweave. And then next is Arweave Polygon. So Polygon on November, they actually announced that they will be storing Arweave natively. So they have chose Arweave to be the data storage partner. And just this week, Polygon also announced that they raised 450 million from Sequoia, SoftBank, and all these tier 1 VCs. Next is Kive. So Kive is middleware. So they want to be like the data pipeline to transport all this data across all the blockchains. So this will help like Polkadot, Cosmos, AVAX to actually store their data through them, and they will actually store them on Arweave. So they are like the middleman between all these other L1 protocols. And they also work together with Graph protocol to query all their data. So this will be helpful, especially for all the developers, because now it makes it easier to query all this data from Arweave. So bullish thesis for Arweave. Number one is Arweave market share is extremely small, and Filecoin is still the dominant leader. This is as of Q3. So Arweave still has a lot of potential to grow. And this is given the fact that they are a more powerful and elegant tech. This is just based on my own opinion. And then Web3 narrative also has not taken off. Right now, all this narrative is just like L1, DeFi, NFTs, but Web3 is actually the most important component for blockchain to take off, because everybody needs to use this kind of middleware layer. And I think the catalyst for Arweave is really this NFT GameFi wave. So as we mentioned just now, when all these things start booming, then you need a lot of data to store all these things, and that is where you have exponential data storage, and you need Arweave to store all these things. And Polygon ecosystem would also be helpful for Arweave, because Polygon just announced this 450 million funding, so it could attract quite a few developers and players into the space. And then Kive, this is also very, very important, because without them, then other blockchains won't be able to use Arweave as of now. So more grants, more devs, more applications, and institution funds coming in. Recently, they just have been put as a watch list on the Grayscale Institution Trust. So all these, I believe, are the bullish thesis for Arweave, and I really think that Arweave is actually a very, very strong project. And I hope this video has given you a better understanding of what Arweave does, the overview of the tech and all this. And that's it. I've come to the end of this video. So if you find this video helpful and meaningful for you, I would appreciate if you can help to like this video, subscribe, and also share. And if you have any questions, discussions, please comment down below, and I'll see you in the next one.